What if the world as we know it suddenly changed? Not overnight, but slowly over thousands of years. Imagine Earth's invisible magnetic shield flipping upside down, leaving our satellites, power grids, and even animals struggling to survive. Scientists warn this rare event could happen soon, but no one knows exactly when. Could you be ready for the day Earth's magnetic field flips? Stay tuned as we uncover the shocking truth behind this hidden threat that affects every living thing on our planet. Don't miss out on what could change life forever. Earth has a magnetic field that works like a giant invisible shield around the planet. This magnetic field protects us from harmful solar winds and cosmic radiation coming from space. It is created by the movement of molten iron inside Earth's core. Normally, the magnetic field has two poles, the North Pole and the South Pole, just like a big bar magnet. A geomagnetic reversal is when these magnetic poles swap places. This means the magnetic North Pole becomes the South Pole, and the South Pole becomes the North Pole. This flip doesn't happen quickly. It takes thousands of years. During this time, the magnetic field can get weaker and more complex before settling into the new direction. Scientists study geomagnetic reversals using rocks and sediments that recorded Earth's magnetic field millions of years ago. These flips have happened many times in Earth's history. Understanding this helps us learn how Earth's magnetic shield works and how it might change in the future. Earth's magnetic field has flipped many times in the past. Scientists have found evidence of these flips in ancient rocks and ocean sediments. These rocks show the direction of the magnetic field when they were formed like a natural record. The last major flip, called the Brunhes-Machiyama reversal, happened about 780,000 years ago. Before that, flips occurred irregularly, sometimes every few 100,000 years, sometimes millions of years apart. These changes are normal and part of Earth's natural magnetic cycle. During these flips, the magnetic field becomes weaker and more complicated. It might have multiple poles instead of just two. This can last for thousands of years before the magnetic field settles in the new direction. Studying this history helps scientists predict what might happen if a flip occurs again soon. While a reversal sounds dramatic, it is a slow process and Earth has survived many flips without major problems. Still, understanding the past is important to prepare for any future changes. Geomagnetic reversals don't happen on a fixed schedule. Scientists say they occur irregularly, sometimes every few 100,000 years, and other times millions of years can pass between flips. On average, a reversal might happen every 200,000 to 300,000 years, but this is only a rough estimate. The last full reversal took place about 780,000 years ago, so some experts wonder if Earth might be due for another one soon. However, it's important to know that these flips don't happen overnight. They can take thousands of years to complete. Between full reversals, the magnetic field can weaken or shift slightly, called excursions. These are temporary changes where the poles move, but don't fully swap. These can last a few hundred years before the field goes back to normal. Because geomagnetic reversals are rare and slow, scientists closely watch changes in Earth's magnetic field to understand when the next flip might start and what effects it could have. Before a geomagnetic reversal happens, there are some important signs scientists look for. One key sign is that Earth's magnetic field starts to weaken. This means the strength of the shield protecting us from solar radiation gets lower. Also, the magnetic poles may begin to move faster and become unstable. Sometimes, more than two magnetic poles can appear in different places around the Earth. This makes the magnetic field more complex and confusing. These changes don't happen suddenly, but over thousands of years. Scientists study these signs carefully to predict if a reversal is coming. Watching the magnetic field today helps us prepare for any future flips and understand their possible effects on technology and life on Earth. When Earth's magnetic field flips, it can cause problems for satellites in space. Satellites rely on the magnetic field for protection against solar winds, streams of charged particles from the sun. These particles can damage satellite electronics and affect their communication systems. During a geomagnetic reversal, the magnetic field becomes weaker and more irregular, giving solar winds a better chance to reach satellites. This can cause more frequent satellite malfunctions or failures. Satellites are also used for GPS, weather forecasting, and communication. If satellites are damaged or disrupted, it could affect these services on Earth, causing problems with navigation, phone signals, and internet. Scientists work on ways to protect satellites from increased solar activity, especially during times when the magnetic field is weak or changing. This helps reduce risks and keeps important satellite systems running smoothly during a reversal. Many animals use Earth's magnetic field to navigate. Birds, sea turtles, whales, and even some insects rely on it to find their way during migration or daily movements. When the magnetic field flips, these animals might get confused because the magnetic poles change places. During a reversal, the magnetic field can become weaker and more irregular. This might make it harder for animals to use their internal compass. Some studies suggest animals could temporarily lose direction or change their migration routes. However, animals have lived through many flips in Earth's history, so they likely adapt over time. Scientists continue to study how these changes affect wildlife and nature to better understand how life on Earth copes with magnetic field changes. This research helps us protect animals during future flips. A geomagnetic reversal can cause serious problems for power grids and technology on Earth. When the magnetic field weakens, Earth becomes more exposed to solar storms, bursts of energy from the sun that send charged particles toward our planet. These solar storms can create strong electric currents in power lines, damaging transformers and causing large power outages. In 1989, a smaller solar storm caused a blackout in Quebec, Canada, showing how vulnerable power grids can be. Besides power grids, other technologies like radio communications, GPS, and even airplanes can be affected. Disruptions in these systems could impact everyday life, including navigation, communication, and safety. To reduce these risks, power companies and governments work to improve grid protections and develop better forecasting of solar storms. This helps prepare for possible magnetic field changes and keeps technology safer during a geomagnetic reversal. Scientists are still studying how a geomagnetic reversal might affect human health. Since Earth's magnetic field protects us from harmful solar radiation, a weaker or changing field could increase exposure to this radiation. Higher radiation levels might cause more cases of skin problems and other health issues. Some researchers also think changes in the magnetic field could affect animals and humans in ways we do not fully understand yet, such as changes in brain activity or sleep patterns. However, Earth's atmosphere still provides strong protection from dangerous radiation, even if the magnetic field weakens. People have lived through many flips in the past without clear evidence of major health problems. Scientists continue to research this area to understand any possible risks better and find ways to protect human health during future geomagnetic reversals. Thanks for watching! If you found this video eye-opening, don't forget to hit the subscribe button for more amazing stories about our planet and beyond. What do you think will be the biggest challenge when Earth's magnetic field flips? Share your thoughts in the comments below. We love hearing from you. And don't miss our next video, The Fermi Paradox: Are We Truly Alone? Get ready to explore the biggest mystery of the universe right here!